Okay, guys, so in this video, we're going to be looking at proving triangles are congruent and then proving that maybe an angle, a pair of angles, or a pair of sides are then congruent, which we can do once you've proven that you have two triangles that are congruent, then you can conclude that any corresponding sides are congruent and any corresponding angles are congruent based off of this rule that we have that is called corresponding parts of congruent triangles are congruent. And thankfully, we can abbreviate all of that as Cpctc. Okay? So, looking at example 1, we are given that angle BAD is congruent to angle BCD, and that of course is given to us. And then we also have that BD bisects angle ABC. So segment BD bisects angle ABC. And again, that is part of our given information. Okay, so since we know that BD bisects angle ABC, then that means we have congruent angles up here by definition of bisects. So let's say that angle ABD is congruent to angle CBD. Okay, and again, that would be by definition of bisects. Okay. Now we have two angles that are congruent, and then I see that we have a common side right here that is congruent to itself. Okay, so we can state that side BD is congruent to side BD by reflexive property. Okay, so now we can state that this triangle on the left, triangle ABD, is congruent to triangle CBD, and that would be by angle side. Triangle ABD is congruent to triangle CBD. And again, that is by angle side. And then we're trying to prove that side AB is congruent to side CB. Okay, so now that I've proven that these two triangles are congruent, I can state that the corresponding sides are congruent. Okay, so now I can state that segment AB is congruent to segment CB, and that would be corresponding parts of congruent triangles are congruent. Okay? Okay, so that's problem number 1. Now let's look at another example, problem number 2. Okay, so we're given that G is the midpoint of EI. And that, of course, is given. Okay, we're also given that segment EF is parallel to GH, and then we're also told segment GF is parallel to IH. Okay, so since we know G is the midpoint of EI, that would mean that this segment should be congruent to that segment. So I'm going to state that segment EG is congruent to segment GI, let's say IG. I got it backwards there. Okay, because if I'm going to do E to G would correspond with I to G, okay? And so that is by definition of midpoint, okay? Now, remember we were told we had parallel lines. Let's mark those, okay? So EF is parallel to GH, and sometimes it'll be helpful if you extend those sides out a little bit. It makes it a little bit easier to see where your corresponding and alternate interior angles are. And we also are told that GF, so this side is parallel to IH, right? So these are parallel. Okay, so then I notice that we have corresponding angles, because here is our transversal that's cutting across my two blue lines here. So therefore I would have this angle and this angle, which would be corresponding. So I have angle GEF, and that would be congruent to angle IGH, and they would be congruent by corresponding angles. Okay, and then we also have this angle along with this angle, okay, that again would be corresponding angles. So we can say angle EGF is congruent to angle GIH, and again that is corresponding angles. Okay, so now if you look at what we have angle, a side, and an angle, and that side that we have that we're showing that is congruent, that's an included side. So now we can state that those two triangles are congruent by angle, side, angle. So triangle EFG would be congruent to triangle GIH. Okay, and so now we're trying to prove that angle EFG, so this angle here, and GHI, we're trying to prove that these two are congruent. Well, now we have corresponding angles, so now we can state that based on our rule that we just started talking about today, which is Cpctc. Okay, so we have that angle EFG is congruent to angle GHI. And that should be it for problem number 2. Okay, so now let's move on and look at problem number 3. Okay, so our given in this problem is that segment NK bisects angle JNL. And we have that segment NL bisects angle KNM. And then we're also told that triangle KNL is an isosceles triangle. Okay, so starting off with the first two things that we're told here about NK bisecting angle JNL. So that would mean NK is here, it's bisecting JNL, so that means these two angles should be congruent. Okay, so I'm going to say that angle JNK is congruent to angle KNL. And then I'm going to go ahead and do it all in one step. Since NL bisects angle KNM, we can state that angle KNL would be congruent to angle LNM, and that would be by definition of bisector or bisects. Okay, now notice how this angle here is included in both of these statements. So therefore, if we know that JNK is congruent to KNL, but KNL is also congruent to angle LNM, therefore the angle JNK must be congruent to angle LNM. And that would be just the transitive property. Okay? Now that's basically everything that the information about those segments bisecting those angles. That helps us with that part, okay? And let me, I didn't mark this one as well, okay? But this is equal to this, which is equal to this, and therefore, since that's the same angle, we can state that JNK is congruent to LMNL, okay? So now we were told that triangle KNL is an isosceles triangle. So that gives us a little bit of more information. We know now that NK is congruent to NL if that is indeed an isosceles triangle. So therefore we know segment NK would be congruent to segment NL, and that's just by definition of an isosceles triangle. And then we had a proof in our last lesson where we had an isosceles triangle, and hope you remember that if we have an isosceles triangle, then we also know that these base angles should be congruent. So now we can state that angle NKL is congruent to angle NLK. And that would be our isosceles angle theorem, or the base angle theorem, however you want to write it. Okay. Okay, so let me mark that. So now we have this angle is congruent to this angle. Okay. Now we're trying to prove that the larger triangle is an isosceles triangle. Okay. So basically, in order to prove that, we need to prove that these two sides here are congruent, and we can prove they're congruent if we could possibly prove that these two triangles on the sides are congruent, because then we could use corresponding parts of congruent triangles are congruent. Okay, so in trying to prove that the triangles on the left and right are congruent, well, right now we've got these two sides, okay, and we basically have these angles, so we really need this other angle down here, because then we could use angle side angle, right? Well, right now all we know is that these two angles are congruent. However, this pair of angles would be a linear pair, and this pair of angles would be a linear pair. Okay, and that is going to help us by substitution, because then we can substitute the fact that these two angles are congruent, and then that would help us to prove that these two angles are congruent. Okay, so first of all, because we're going to use the fact that we just stated that these two angles are congruent to help us do that. So first of all, I need to state that these two angles are a linear pair, and these two angles form a linear pair. Okay, so I'm going to write the measure of angle NKJ, that's this angle here, NKJ, plus the measure of angle NKL, so that's this angle here, NKL, those total up to be 180 degrees. And likewise, we can say that the measure of angle NLM plus the measure of angle NLK, this angle here, NLK, those total up to be 180 degrees. Okay, and so that is, we can state that by, there's a linear pair postulate. Okay, so again, notice back up here, we stated that angle NKL is congruent to angle NLK. So we've notated that these two are the same. So since we've done that, now we can set these two things equal to each other and use that information to help us prove that this angle here is congruent to this angle over here. Okay, so since both of those are 180 degrees, I can set them equal to each other. So the measure of angle NKJ plus the measure of angle NKL is equal to the measure of angle NLM plus the measure of angle NLK. And that is by substitution, the substitution property of equality. Okay, now since we've made this statement up here in red, now we can cancel these two things out, okay, because if they're equal, if I cancel those out, then I can state, and I'm going to come up here on the left-hand side because I'm running out of room down here at the bottom. We can state that angle NKJ is congruent to angle NLM. And again, that would be I'm running out of room. Substitution probability of equality. Okay? Okay. Now, next thing, now that we've proven that these two angles are congruent, and let me mark those. So this is congruent to this. So now we can state these two triangles on the outside here are congruent because we've got angle, side, angle. So triangle NKJ is congruent to triangle NLM, and that would be by angle, side, angle. And now that I've stated that these two triangles are congruent, we can state these two sides, okay, NJ and NM, we can state that they are congruent. So segment JN is congruent to segment MN, and that would be by corresponding parts of congruent triangles are congruent. And now, if those two sides are congruent, if this side is congruent to this side, then that tells me that that has to be an isosceles triangle. So triangle JNM is an isosceles triangle based on definition of an isosceles triangle. Okay, and so that is the proof for number 3. Now, let's look at 2 more rules or postulates that are going to allow us to prove certain things. So the top one is corresponding angles of similar triangles are congruent. Okay, so if we can prove that two triangles are similar, then all pairs of angles between both the triangles are congruent. So corresponding angles of similar triangles are congruent. And then corresponding sides of similar triangles are proportional. So again, if you can prove that two triangles are similar, then all pairs of sides are going to have equivalent ratios. Okay? Okay, so let's look at an example. Okay? This is proof number 4. So we are given that angle OPQ is congruent to angle SRQ. So OPQ and SRQ. Okay, so then just by looking at the figure, we know we have vertical angles here. So we can state that angle PQO, so this angle here, is congruent to angle RQS, and that would be by vertical angles. Okay, so that has given us two corresponding angles that are congruent. So therefore, we can state that our triangles are similar by angle-angle similarity. So triangle PQO is similar to triangle RQS. Now that we've stated that those are similar triangles, we're trying to prove that PQ is to QR as OQ is to QS. So we're trying to prove that these two pairs of sides are proportional, which we can do now that we've proven that our triangles are similar. So PQ is to QR as OQ is to QS, and that would be the rule that we just discussed, or one of them. Corresponding sides of similar triangles are proportional. Corresponding sides of similar triangles are proportional. Csstp. Okay, now problem number 5. Okay, so we are given that TV is 4, UV is 8, and UX is 6. And we're also told that UV, segment UV, is a perpendicular bisector of segment TW. Okay, so again, if we have a perpendicular bisector, then that tells us that we have right angles. Okay, so if UV is bisecting TU, then we have right angles being formed here. So we can state that angle U VT, so this angle here, and angle WVX, so this angle here, are right angles. And that's just by definition of perpendicular. Okay? And now we can state that those two angles are congruent because all right angles are congruent. So angle UVT is congruent to angle WVX, and that would be all right angles are congruent. Okay, so also when we're told something's a perpendicular bisector, then we know that it bisects that segment into two equal pieces. So therefore we know that segment TV is going to be congruent to segment WV, and that would be by definition of bisector. Okay. Now we need to use this other information that we were given about the lengths of the sides, okay? So if we're looking at our two triangles, UV would correspond with WV. So UV and WV. And based on the information that we're given, UV is 8. We're not told what WV is. However, we're told that TV is 4, and we know that this is bisecting that side, okay? We stated that up here, that those two segments are congruent, so therefore WV should be 4. Okay, and so then we're also told that TV is 4, And that would correspond to side XV. And if remember, UV was 8, okay? But we're also told that UX is 6. So therefore, that means that that XV would have to be 2. And all we're doing here is substitution. And then I can simplify that a little bit, okay? So therefore, UV is to WV as TV is to XV, and all of that simplifies to be 2, which means they're proportional. So that's just definition of proportions. Okay? Okay, so what we have here is we've proven that we've got 2 pairs of sides that are proportional. And don't forget, we proved that these 2 angles are congruent, and that's the included angle between the proportional sides. So therefore, we can now state that these 2 triangles are similar. So triangle TUV would be proportional or similar to triangle XWV. Okay? And that would be by side angle side similarity. And now that I've proven that these 2 triangles are similar, we're trying to prove that angle TUV is congruent to angle XWV. And so now I can do that by corresponding angles of similar triangles are congruent. So angle TUV would be congruent to angle XWV. And that finalizes problem number 5 for us.